Alright, welcome back, arcade and electronics enthusiasts. Here on the bench I just got out of the box, this is a Gravitar PCB. Nice vector game, very tough Atari vector color game. Yeah, this game is notoriously hard, but it's pretty darn cool. This is the Gravitar board. This is actually, I believe, the same board as a Black Widow. I believe it's just a ROM swap between Black Widow and Gravitar. I could be wrong on that, but that's what I think. So anyway, this one is Gravitar. So we're going to get to looking at this one. Yeah, I think it says Gravitar right there. Yeah, Gravitar. So we're going to go ahead and get this one looked at. Kind of dirty. Kind of a dirty board. Dusty. Very dusty. Okay. It's got two pokey chips. It's got a 6502. These are 20... Those 25? 2532? 2532 chips. 2532. This is a RAM, 6116 RAM. Got one of those EA ROMs. EA2055, I believe. Okay, got more 2532 chips up here. Another 6116. Got an Atari AVG, analog vector generator chip. And this chip basically right here took the place of the auxiliary board, that Tempest and Battlezone and all of, not all of, but, basically Tempest and Battlezone had the auxiliary board. This kind of took the place of that, this one chip. So, yeah. These are notorious for being bad. We have a tantalum capacitor right here that likes to short. We have what looks to be a negative and positive 15 volt regulators to provide that voltage to the, I believe it's to these two DACs and the op amps. I think these two get that voltage too. I'm not 100%. I'd have to look at the schematic. But okay. All right. So before I do anything, we will make sure this guy is not shorted. That will get replaced as well as the regulators. Just maintenance type stuff. Okay. Got our 12.096 crystal mica capacitors for the oscillator circuit. There's a bipolar. 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 And this has got more bipolars on it. We got a little bank of counters right here, probably for vector timer, I would imagine. TL082, that is probably power on reset right there. Excellent. A lot of sound circuitry right in here, a lot of analog type stuff. We have our op amps, LM324s, and you do have your two pokies right here. So this is a lot of, this is probably a timer I see, a 555. Yes, 555. Okay. And you got your poly Polypropylene capacitors in the audio section. Okay. Yeah, this thing will need to be cleaned up. It's pretty dirty. Pretty dirty, but it will be okay. And we got another mica capacitor up here, mica capacitors up in here, all over the place. The reason that mica capacitors are used in these sections is they are signal capacitors, and they are very, very super stable capacitors. They do not drift at all due to heat or anything like that, noise, anything like that. They're super stable capacitors. You'll see mica capacitors, you'll see in oscillator circuits and critical signal circuits like this. You'll see your basic ceramic caps are always decoupling. Ceramic capacitors should never be used in this kind of, where these micas are at. Should never use ceramics in those places, because ceramics are very unstable. They're basically only used in decoupling. That's pretty much it. Or coupling, coupling stages together or something like that. Like in audio sometimes. Well, audio generally you'll see these polys. Yeah, anyway, a little bit of a capacitor rant. Or info dump, however you want to look at it. And that's why you'll never see ceramic caps in an oscillator circuit, because they are just so unstable. You touch them and the capacitance can change. They heat up a little bit. If the cabinet is warm and they heat up, it'll change the capacitance. So it changes just changes the property of the whole circuit. And that is why you have micas. Micas are super stable. They do not fluctuate due to heat or anything like that, noise. So a little bit of a cap lesson, capacitor lesson. All right. So, anywho, let me grab my harness for this. We'll hook it up. We'll hook it up to the little black scope, which, you know what I need to do is I need to open this black scope up. And I think that I have a capacitor that blew up or something, actually years ago, a couple years ago. And I've been using it ever since. The intensity has no control at all. So I think a cap popped in this thing, and I really need to open it up and go over that circuit. See if I can find a schematic on this guy and do a little bit of a repair on this thing. Would be nice, but that's either here nor there. But anyway. All right, let me go ahead and grab this harness. We'll hook this thing up, fire it up, and see what it does. And I would imagine it doesn't do anything. And we'll have to look at this guy. This will be a culprit. These are culprits. The pokies. RAM. Does this thing have any other kind of RAM on it? 2114s or anything like that? Not that I see. What is the working RAM on this thing? Just this guy? 2K of RAM for that, maybe? 2K of working RAM? Okay, cool. How about vector RAM? That's got to be this guy, right? 2K of vector RAM. Okay, yeah. Let's get this thing hooked up and see what we get. I just got my harness out, and honestly, I have not done one of these boards in a couple of years. The last one that I did was I did 2 Space Duel repairs, and that's been probably 2 years ago. So this is the first time I'm getting this harness back out. And I gotta say, I'm pretty impressed with this harness that I put together. Look at this thing. I have Gravitar. It's labeled Gravitar. So that's where I plug in my Atari joystick for Gravitar. I have, what is this? This is Black Widow Fire, because Black Widow, you know, has 2 sticks. So that's the Fire. And then I have, you know, Black Widow Move. So I got one for the movement side of Black Widow, one for the fire side. Player 2 for Space Duel, Space Duel Player 1. Yeah, this is pretty impressive. Digging this. What is this one? Space Duel, Black Widow. Yeah, I only got one for Gravitar, I guess. Gravitar start, Space Duel start. So obviously the controls, the pinouts are different for every game, obviously. So I've already got that all taken care of. That is pretty impressive. I do have to, once I verify I don't need to tap anything else, I'll hot glue these so that they don't break. I'll hot glue them stable. But yeah, that's pretty sweet. So let's go ahead and hook this thing up. Okay, we are all hooked up. Got that guy ready to go. We have, I'm going to monitor 5 volts and we're going to turn it on. 4.6. Let's turn up the voltage a little bit. There's 5 volts, basically. And I rebuilt another small AR. This is an original, I believe, Asteroids. I just rebuilt this guy. So I'm running my 5 volts regulated off of that. Yeah. I completely rebuilt that. Completely. This new caps, new regulator here, or new power pass transistor, new little driver transistor right there. The sound amps are new. I rebuilt this little section right here, all those little caps and stuff, resistors, it was kind of corroded. Oh yeah, I rebuilt that little guy. So now I have 3 ARs in my setup. But yeah, this thing isn't doing anything. Nothing. So let's go to test. See if it does anything in test. And it does nothing. So I'll have to get the logic probe out and start just kind of probing around a little bit and see if we get anything. See if we're getting any activity at all. Yeah. All right. I'll be back. Okey-doke. I'm just going to do a little probing around. All right. And we do have some tabs here that we can look at. We have clock signals. Uh-oh. There's no clock. 37 is the clock and it's low. 37. No clock. Reset's low. Up here. Oh, we got pulsing here off of the crystal. So it looks like our syncing signals are dead. So this is definitely schematic. Definitely a schematic thing. Yeah, we know that our crystal is crystalline. And this guy right here is going to be emitter base collector, and it's probably collector is the signal coming off. Base emitter base collector, so yeah, emitter base to emitter. The collector will be tied to 5 volts, and the base, the crystal signal will be coming into the base and down the emitter, and the collector will just be supplying extra current down through the emitter. Or anyway, yeah, that is working fine. We have that. The crystal is crystalline, but there's no clock getting to the CPU. And the question is, where does that come from? And the only way to answer that is to get a schematic and find out. My what I think is going on is the crystal is crystalline, and that 12 megahertz is going to counters being divided down and then sent to the board to run everything. And somewhere along that line is death. Now we do have some 161s up here, but I think these are probably vector timer. Well, the clock's going in there. That's low, though. That's not going to count with that being low. Okay. Yeah. With pin 7 being low, those won't count. So those, I would suspect those are the vector timer counters. We should have some other 161s somewhere. I'm just going to have to get, we got 74s here. '74 clocking pin. No such luck. We're not going to be able to. Here's a 109. Okay. I don't know the pin out of a 109 right off. Yeah, I don't know. Okay. Well, I'm going to have to grab this schematic and follow this clock signal, follow the crystal signal, find out where it goes, because somewhere it's not making its way to the CPU. It's dead somewhere before it gets there. So we shall see. All right, I just went ahead and took an opportunity to clean this board up, and it was super filthy. I mean, the amount of dirt and dust that came off of this thing was pretty impressive. Sockets are in pretty good shape all around. looking shiny, so it should be okay. Yep. It's nice and clean now. We'll get back at this thing. I think I'm going to go... It's Sunday today, so I think I'm going to go to the print shop tomorrow and print off Gravitar schematics and pick this one up tomorrow, Monday. I think I've done enough for a Sunday. Oops. Yep. So that's going to do it. We'll see you then. I'll be back tomorrow. Just let this thing dry off really good. It's looking beautiful though. Maybe I'll go ahead and do some of my maintenance stuff with the regulators, get this tantalum out of here. And that's really all I need to do. So, and you know what I could do is I could go ahead and just verify the software set. I think, because I do like to do that. I like to know that all of the software and the RAM, all the memory that is removable from the board. I'm not talking about any RAM that's soldered into the board or anything like that, but the removable software memory, software and RAM memory is good. I like to know that going in. So I could go ahead and just do that. So I probably will. So we'll see you tomorrow. I got the board all cleaned up. I don't have any chips in it. I'm just looking at the clock off of the crystal on this scope, and it actually looks really good. I'm not going to mess with this scope. I'm not going to open it up and mess with it. I just don't have time for that, but I think that looks pretty darn good. I got it set at point, or is that one microsecond per division? Damn. So 1 microsecond per division. Boom. I guess it'd be easier to make it bigger. Yeah. Well, it looks really nice. Now it's at 10 times magnify. Yeah. Anyway, it looks good. Pretty cool. So, yeah. All right, yeah, I just wanted to add that little thing. This thing actually, for a nice little analog scope, doesn't look bad. I only use this thing for a vector screen. That's the only thing I use this thing for. So, all right, well, we'll see you. All right. Just kind of looking at this. How do we get frequency from this? How do you tell what the frequency is? Well, you have to have this thing all the way to calibration, I believe. Which is, see, you can scale it down, you can scale it up. I think you have to have it all the way where it says all the way that way, calibrate. I don't think you want it variable, to be honest. I don't know exactly. But anyway, this is set to 0.5. See, here's 0.2. gets bigger, and then XY. So here's 0.5. The frequency equation is F equals 1 over the period, basically, the time it takes to do a cycle. So if you look at this here, there's your cycle right there. So it looks like it's almost, but not quite, 2 divisions. I'd say maybe 1.824. Yeah, let's say 1. Okay, 2, 4, 6, 8, 7, 5. Let's say 8, because this really should be like that. Yeah, what's 1.75? I don't know. Anyway, let's take calculator. 0.5 times, that's the, remember, 0.5 is our setting, 0.5 microseconds, times what, let's say 1.8, and that's 0.9. 0.9. So frequency is 1 over 0.9 microseconds, but we have to convert it to seconds. So 0.9 equals, that would be milli. That's seconds, 0.9. And that can't be right because that's only 1 megahertz. Let's try that again. 1.8 times 2 equals, wait, 1.8 times 0.5 is 0.9. And that would be 1, 2, 3, 4, 5, 6. 0.9. And it's 1 over that. Hmm. .8 times 0.5 is 0.9. I'll be back. I got to think about this. Why am I only getting 1 megahertz? All right, well, I figured out what I had wrong. I had this pulled out. I had this pulled out times 10 magnification. So that is minus 10 times magnification. So I had this thing pulled out. So that 1.1 megahertz that I had, multiply that by 10. So 11.1 megahertz or whatever. So, you know, give or take, it's a 12 megahertz crystal. So, yeah, that's why it wasn't adding up. Is because I did not realize that I had times 10 pulled. So you have to multiply it by 10. So that made sense. Yeah, frequency equals 1 over the period. And the period looks like I have it at 0.5, or what do I have it at here? Let's go to 0.2 and go magnified 10 times. It's better to just, if you're magnifying 10 times, it's better to go to 0.5 microseconds per division. And we have our period at almost 2 divisions. It's almost 2. It's 1.8, really. So once again, do this once again. 1.8 divisions at 0.5 microseconds equals 0.9. Now let's multiply this times 10 because we have it 10 times magnification. So 1 over yeah, that didn't work. Jeez, goodness gracious. 0.9. 1 over times, and then this times 10. There it is. 11 megahertz. 11.1 megahertz based on that, but you know, it's pretty darn close. Pretty darn close, really. Yeah. All right. Yeah. It's been a long time since I've messed around with doing that kind of math. All right, we'll get back to this thing after, I don't know, tomorrow, I guess. See you then. Okay, I have this thing all cleaned and put back together. All right. And I did some probing around. I had it hooked up and I turned it on and it was doing the same thing it did before, where there was no life, no clock on here. And it turned out that I had to switch from the Asteroids power supply to the normal power supply because I did not have 10.3 volts going to here, which powered this op amp, which is the power on reset. So got that working right, plugged it in, it's working. We have something going on, but I can see that it looks like the letters are all skewed. Maybe I'm gonna have to put it on the vector monitor and take a look at it. It looks like the words are all doing that, which indicates to me that it's probably this DAC. So yeah, I'm gonna go ahead and throw this thing up on the vector monitor here and take a look at it. Okay, yeah, that looks a slight bit ugly. All right, yeah, yikes. I'm going to turn that off. I don't like that. And I'm going to go ahead and unhook this and socket and replace this DAC because I believe it's an issue. So let's start there. It looks like the problem is all up here so far. So I'll go ahead and do that. All right, I did remove this DAC and replaced it because that was not an issue. It didn't make any change. So I just went ahead and I'm probing the outputs. And this is the X output. And to me that looks pretty healthy. I don't know exactly what it's supposed to look like, but as far as from reference, we're getting plenty of positive and plenty of negative, so that tells me that we're getting equal spacing from zero, see? If I probe the Y output, it seems like it's nowhere near even. It just doesn't look anything like the X output. I mean, I don't expect it to look exactly like the X output, but I would expect it to be kind of even amongst the reference anyway. I think the problem is the Y output. And what I want to do is put this back on here. Kind of just grab this Y output. And you'll see how it's kind of stepped like that? And see how this is kind of stepped? I'm wondering if that correlates. I'm sure it does correlate. It has to, right? So I believe that there is a problem with the Y output. And I got my Chimatic here. So I think I will just kind of start going over the Y, work back on the Y circuit. Okay, I changed this DAC. This is the Y DAC, because it looked like the signal coming out of that basically just did not look as good as the signal coming out of X. And I believe that fixed it. Yeah, it's looking way better. And you'll actually see the Gravitar screen. See that? Yeah. So let's turn it off and hook it up to the vector monitor and make sure that all of the other, the colors and all that are right. So, yeah, let's do that. But it looks like it was the DAC. This DAC, the actual DAC. So I was going to remove this switch as well in the Y circuit, this one here, but I got to thinking I don't think it was a switch problem. I just stopped. I was like, I'm going to just do this because it looked like it was a signal issue. So the switch looked like it was actually working, which it was. So, all right, I'm going to go ahead and put it up on the vector monitor and take a look. All right, so I have it hooked up to the vector monitor, and the colors are not right, and neither is the blanking. So there are more issues, and those are digital problems. Yeah, see, that's like black and white for the most part. There might be a touch of blue. I see a touch of blue. Heck, this might just be blanking. Colors might be okay. It might be totally a blanking issue. So, all right, I am going to go ahead and turn the vector monitor off. I don't need this thing, doing this. And we'll look at the Z blanking circuitry. Let's fix that first, and then if we still have color issues, then we can do that. But first things first, let's get this thing. Let's get the Z blanking circuit working properly. So we'll take a look at that without the vector monitor hooked up. I don't need to have that for that. So, all right, be right back. Okay, I have found the blanking issue. It is either one of these chips. And it's right here. I went through all this. This all looked good. Z intensity and blanking. And then I followed the signals up to here. This is Z blank. Z blank and blank. Come up here. And this L10 and K10, and this is a 7433, which I'm not sure if I have a 7433 at all, so I'm hoping it's not this chip. I don't know exactly what a 7433 is. I'll have to look it up. But that's the 7433, and this is the 74175. And, oops. I'll just probe some of the outputs. There's an output. That's pin 3. Okay. Yeah, pin 3 on the 175. What is pin 3? Oh, pin 3 off of the 175 is an output, which inputs pin 2 of this guy. You can see that's just no good. And here's another output from the 175. Look at that. Garbage. 175. This is pin 9, 10, 11. So pin 11 is connected to this 7433. Pin 10 isn't connected to anything, and you'll see it is fine. I'm kind of thinking it's this chip that's corrupting the outputs from this chip, which sucks because that's a 7433, which I know I don't have a 7433. So I don't know exactly what that is. It looks like a not and, 2 lows to get a high, 2 highs to get a low. That's actually a NOR. 2 lows to get a high. 2 zeros to get a 1. Yes, it's a not or. Okay. Is it open? It's got to be open collector, right? It's probably an open collector, so it doesn't exactly drive high. That's pin 1. That's an output. That just doesn't look good. Man, that's an input. That's 4 and 5 out to 6. That's an input. And that's just looks like crap. This is where the problem is. It's one of these 2 chips, and I think it's this 33. I really do. So I'm going to have to dig around and see if I can't find that. I might have to order 7433. So, oh well. Okay, I'll be back. All right. It turns out I do have 7433s. So I just replaced both of them. So I'm going to go ahead and unplug that, plug in my power supply, and turn it on. And we'll see how it looks. Uh-oh. Oh, I think I have to adjust my BIP pots, but it looks great. As long as I can adjust that. Let's go into test. Let me see if I can adjust this out. Alright, yeah, I really had to give these a good shot of deoxit, all these pots, and worked them all. And it's looking pretty good. It's actually looking like I need to adjust the yoke. The yoke needs to turn a little bit. Maybe. Yeah, absolutely. Looks like the yoke needs to turn a little bit. I don't know. It's not bad. Anyway, yeah. I replaced these two guys. I'm going to make it a little smaller. Size pots. Just make it a little bit smaller. It was a little bit big. That looks better. I might even make it a little smaller yet. What do I need to be driving this monitor so hard for? Yeah, that's better. It does look a little skewed almost. That's got to be the bip. I got to adjust the bips a little bit more. Not that one. There. How's that? I think it just needed a little bip adjustment. Yeah, that's a lot better. More even. Cool. Let's play Gravitar. Okay. It's time to play this baby. It's a tough one too. Oh, coin, coin, coin. Where's my coin? There it is. Uh-oh. False start. This game is so hard. Come on. Oh, that's not fuel. This game is so hard. Oh, game over? Come on. That's on free play. Okay, let's go. And let's go over here. Eh. this is impossible. This is, I can't believe how hard this is. Holy Toledo. This game's almost unplayable. Game over. Wow. That was a quick quarter. In my opinion, I think this is the hardest game ever created. Seriously. Dead. Oh! Oh, mission complete. I'm like, where is everything? Well, I smoked that level. No, forget it. Damn it. Alright, that is enough. Holy. Oof. Holy Toledo. Batman. Hey, I'm on the board. I wonder if how many scores it saves. Anyway. Awesome. Gravitar is a cool game, but goodness gracious, is it hard. Okie doke. Gravitar. So, well, let's do a recap on Gravitar. I thoroughly washed this board. It was so dirty. So much dirt came off of this board. I did wash it very good. I thought that this ROM was bad because it did not verify to MAME. What I failed to do was realize this is not a 2532. It's a 2516. So it's actually, the file was actually good once I realized what chip it was. Had a bad deck. This deck is not bad. New regulators. I got rid of the tantalum capacitor. I replaced both of these chips in the Z-blank circuit because one of them was bad and quite possibly both of them, but more than likely one of them was bad, making the other look bad. And I didn't know which one it was exactly, so I just replaced both of them. Yeah. That's really it. That's all she wrote. So we had Z blanking, we had bad Y, DAC. and a little maintenance. One cap, couple of regulators. And that's all. And some, squirted some good deoxit in those pots and worked them in there really good to make them solid. And that's all it really takes to get your Gravitar back rolling. All right. As always, thanks for watching. And thanks to, I got a couple recent new patrons. Thank you. You know who you are if you're watching. Appreciate it. And we will see you guys on the next Classic Arcade Repair. Thank you much, and bye for now.